Good morning, good afternoon, or good evening, depending upon where you are in the world. And welcome to today's BlackHat webinar, From Live Exploitation to Zero-Day Discovery, Investigating Attacks on Gogs, sponsored by Binalyze and broadcast by Informa Connect. I'm Steve Paul, I'm your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. On the right side of your screen, you'll find the Navigation Center. Here you can participate in the attendee chat, submit questions for our speakers, or download resources. Slides will advance automatically throughout the event. If at any time you experience difficulties with the audio or advancing slides, simply press your F5 key or Command R to refresh your webinar console. If you experience technical issues, please type your issue into the Q&A area, and we'll be glad to offer one-on-one assistance. Towards the end of our webinar, we'll ask you to complete our survey. Please take a minute to fill out the survey before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And now on to the presentation. Joining us today will be Yara Shriki, threat researcher with Wiz, Jilly Tikochinsky, malware researcher, also with Wiz, and we'll also hear from Lee Sult, chief investigator with Binalyze. First, we're going to hear from, turn it over to Lee.
Thanks, Steve. Thanks, everybody. A little about my background first. I was the first forward deployed security engineer at Palantir, where we focused on engagements involving 200,000 endpoints or more. I then went on to co-found Harangi Cybersecurity, the first cybersecurity startup in Singapore, later acquired by Bitdefender. And I'm now the chief investigator at Binalyze, where we help our partners and customers build legitimately world-class incident response programs around our platform, Binalyze Air, the type of thing you use to investigate what we're talking about today. But of course, you guys want to hear something far more interesting than that. So today we're going to explore a well-detailed example of what I think is a looming trend in adversary behavior. I believe this style of attack is becoming more frequent due to the rise of vibe coding, and it's effectively the reemergence of shadow IT for any of those responders who lived through the nightmare of evidence collection and analysis that was. But I'm honored to join two tier 1, and that's the top tier, operators who have documented their very interesting and quite relevant incident response case. Now, just so the audience knows, we really want this to be a conversation, so please drop your questions into the Q&A. I'll be taking a look at that, and we want to turn this into a discussion. So please, without further ado, Gili and Yara, let's take it away.
So as Lee mentioned, please ask your questions in the chat. We want this to be a discussion. We want this to be interactive. We will really love as much engagement as possible. So from zero exploitation to 0-day, investigating attacks on Gogs. Now, this incident started with me receiving an alert in our internal Yara alert systems. This is an alert that tells me that some customer has a malicious binary in one of their machines. And obviously, one of the first things we do when we see such malware is try to investigate how did the malware get there. Wait a second. Yeah, how did the malware get there? Because more interesting than the malware itself is what was the intrusion and the initial access vector. So we checked common attack vectors like weak passwords, OpenSSH, RDPs, stuff like that, but the machine was clean. We checked anything else on the machine that might be exposed or maybe has some known 0 days related to the technologies that we found on the machine, but none of them were viable. None of them were relevant to our case. So we came to the only possible conclusion. We had found a live 0-day by accident. So as Lee mentioned, I am Gil Tikoczynski, a malware researcher at Wiz.
And I'm Yara Shriki. I'm a threat researcher at Wiz. We work on emerging threats in cloud environments and investigate them.
Exactly. Yeah, we work on the same team, investigating threats and malware in cloud environments. So now let's dig into more detail about our investigation. As I mentioned, it started with a single alert that we got in our internal systems, and that happened on July 15th. We got a single alert that one machine in a customer's environment was compromised with a piece of malware. Now, a little bit of background about this internal system that I mentioned. It is based on a pattern recognition software called Yara. Yara is a system that allows you to write pattern rules. You write the strings that you want to look for in files and the logical connections between those strings. And then it allows you to quickly scan a lot of files in customer environments and find whatever you are looking for that is suspicious. Because of recent trends in attacker activity, I specifically looked for binaries compiled with a special obfuscator called Go Obfuscate, and that is what led us at the start of this investigation. And like as I said in the alert, you can see it said Go Garble binary. That's the system that I was that's the specific signature that I was looking for in the malware. So Mira started looking at the machine that we found the malware on. First, we saw that it had the malware finding. That's where the investigation began. We then saw that the server also had what we call an attack surface. That means an exposed web server and that is accessible publicly. And the relevant technology on the machine that serves this web server was something called Gogs. Now, at the time, we had no idea what Gogs was. But that is the first key takeaway that we had from this investigation. When you already know that a machine is compromised, you should check all possible attack vectors. That is the easiest way to find how the attackers got in, and you're bound to find something interesting. Because if you have a compromise, it means that one of those attack vectors is compromised, is vulnerable. And now Yara can talk about.
Yeah, so as Gil said, the first question we had was, what is Gogs? We know that we have a server, a customer's environment that is infected with malware, and the only known technology on the server is Gogs. So of course, we looked it up on Google, and we saw that it's a self-hosted Git service. So just to review what is a self-hosted Git service, it basically means that you can host your own Git repository and control everything in a self-hosted server. So of course, it has some pros and cons, or as I like to call them, power-ups and weaknesses. So a very short brief of what the pros and cons of self-hosted Git. You have full control over the server. You can manage all of the repository, the users, and how everything integrates in your own environment. Of course, you have full privacy over everything if you choose to make the server private and internal and not expose it to the internet. But as we saw in our investigation, many of the servers were actually exposed to the internet and also didn't have any security measures that stopped attackers or other users from creating new users and new repositories and attacking the server.
Now, is this the type of thing that you guys think would, like a OpenClaw or CloudBot or Moltbot or whatever, is this the type of thing that you guys would suspect get deployed by some agentic system like that accidentally?
Definitely. Yeah, I think there are several images of Showdown of how many OpenClaw instances are exposed just to the internet. and exposing the ones that the users to any attack, to an attack surface of creating maybe new skills or running code execution. There were just in the last week or 2 weeks many vulnerabilities and malicious skills that were published by attackers.
And it's really interesting. It's really interesting thinking about the correlations with shadow IT, because now we have potential or agentic systems that are potentially installing things users and owners of these systems are not aware of. And what an interesting problem for the industry to solve. And when you get to it, when you get to the point where you start talking about, you realize it was a 0 day. I'd love to hear kind of the emotion around that. Back in the day, we used to do little giddy dances when we would get root on boxes the first time or find something for the first time. So I'd love for you to get your perspective when you get to that point.
Will do. Yeah. So as you said, with all of this exposed server and the fact that it's a Git service, it has many downsides to it, where Gogs is a small project, so it has it has less security than the big projects. So when you compare it to GitHub or Bitbucket, there are less maintainers that are working on it and have less time to actually work on security fixes to new vulnerabilities that come out. And it requires a high maintenance effort by either DevOps, the ones installing the software on the server. You have to manage yourself all of the security patches and keep up to date to the latest version. So of course it has the high maintenance effort. Okay, so we have the GOG server. At this point, we just started to look what are the previous CVEs that it has. Maybe the initial access for the attacker dropping the malware was an older CVE that might have worked on this machine. So we, of course, looked it up. We saw a bunch of vulnerabilities, high and critical, that led to remote code execution. And we tried them out. We looked for any public POC, but none of the public POCs worked on the server. We made a test environment that simulated the customer's environment. We didn't run anything on that environment, but on our own test environment, and none of it worked. So that was when we realized that it's a 0 day. And if you want to talk more about the excitement, Gil.
Yeah, at this point, when none of the previous CVEs worked, we understood that what we have is a new 0 day, because we know for sure that the customer was compromised, when we know that that's the initial access vector, but none of the old CVEs worked. So here we got really excited. We still weren't 100% sure. That will come later when we actually find the 0 day ourselves. And Yara will talk there about the different APIs and the stuff that we had to research. But when we get there, it will be very fun. But for now in our investigation, we have two new key points. We know that the latest version of Gogs at the time was released on June 9th. But the first indication of exploitation that we saw in a customer environment was July 10th, which means something is off. By this point, the customer had the latest version. The program should be completely secure, and nothing should be compromised. But the fact is that the machine was. So we had to go back to the machine and understand what happened. We opened up the web interface of Gogs, and immediately we saw something very odd. Gogs contained multiple repositories with random-looking username and repo names. As you can see here, that doesn't look like a name that the person would choose. We clicked on one of those repositories, and we saw that it contained a single symbolic link. Now, any one of you who used vulnerabilities or studied vulnerabilities can tell you that symbolic links usually means bad things are happening. They are very complicated for programs to handle. They cause a lot of confusion, and a lot of very well-known CVEs rely on the fact that symbolic links are badly managed in a lot of programs. So just a quick, very quick breakdown of what exactly a symbolic link is. Symbolic links are just files that point to other files. They don't contain any content themselves. They just contain a pointer to a different place in the file system. This confusion can sometimes make programs think they're accessing a file in a certain path, while actually modifying the content or deleting or creating a file in a completely different place in the file system, which bypasses a bunch of security lockdown that you do when you're trying to limit programs to their specific domain, to their specific area in the file system. So now that we knew that symbolic links were a key part of how the attacker got in the machine, we looked back at those old CVEs that Yara mentioned and tried to look for stuff that seemed familiar. The first was an old CVE that allowed an attacker to write a file to an arbitrary path and then gain SSH access to the server. And the second was, a vulnerability that allowed the user to edit a crafted symlink in order to modify files on the machine.
So now going a little bit deeper into each of these CVEs. The first CVE was a path traversal, as Gil said, in the put contents API. And it basically lets anyone to write file outside of the Git repository. So that means an attacker can exploit or abuse this vulnerability to write files, any files that they want outside of their repository. And we'll see later how it actually leads to remote code execution. And the fix for this vulnerability is really easy, just one line. It basically just adding input validation on the path parameter, which blocks the path traversal. And the second vulnerability in the editing of the symlink contents, it's a vulnerability in the web editor user interface. So in this specific code, it lets anyone to edit the content of symbolic links. And as Gil mentioned, editing the symbolic link means you actually edit the actual file. So again, an attacker can abuse this to overwrite any file that they want on the server. Now, the fix for this vulnerability, as you can see below, is just blocking any editing of symbolic link files. Now, just note that this fix was only done in the code of the web editor user interface. So if we recap the two vulnerabilities and the fixes, we know that the put contents API was fixed. It was fixed for the path traversal vulnerability, but only in the code of the web editor user interface. So it was never actually fixed to block editing of symbolic links.
Yeah, so then we tried to implement our own zero-day, combining these two vulnerabilities together. Put contents had no symbolic link protections, which means that by creating a symbolic link and then using this internal API, we have an arbitrary right to any file in the server. We then took inspiration from the attacker, knowing that they created a single symbolic link to .git config, and we saw that the .git config file contained a property called SSH command, which is executed whenever the repository is accessed. So by overriding this file and writing in the SSH command whatever bash command we wanted to execute, it will then be executed on the server immediately. So that allows an attacker to have an arbitrary code execution on any Gogs server that they can create a repository in.
Now, when you guys discovered this and you're pulling some of this evidence back, we see some of the random Git repo names, and that looks very much like a smash and grab or bad, like maybe some exploration phase or something along those lines. Would you consider, does this attack to you look like a smash and grab, or what did the attacker's techniques evolve and become cleaner over time, or how would you describe, like how does the case feel to you as an investigator? Because a lot of us have to go off of our gut feel when we encounter these things for the first time.
So there's two parts to this. The first part is that I really think that we saw an evolution of the attacker during our investigation, because we did see different kind of these random looking repos, some with just a symbolic link, some with like a README file. It looked like they were experimenting with making it work on multiple machines and multiple versions, and ended up, as we saw, making the finalized version that works well. And we do think it is some kind of smash and grab or some kind of very opportunistic attacker, simply by looking at the fact that they didn't try to hide their tracks. They could have created the repository with private permissions. They could have deleted it after gaining access to the server. There were a lot of optimizations that a more well-funded state actor would have done if they had this vulnerability to make it more stealthy. But our actor, we think they just wanted to do the most damage or like the most impact they could as fast as they could, and didn't think about the implications and how they can be tracked using those repositories.
So, has some similar corollaries to SQL injection attacks a little, where you just spray SQL all over the place until something lands, and then once you start getting interaction, you just refine that process until you get an injection that just works.
Yeah, and that's why in a lot of servers we also saw like the attacker didn't create a single repository. We saw multiple repositories, maybe as you said, an exploratory phase of trying different commands to see the structure of the server, what is on it. They never just did one command and that's it. There was always some kind of multiple commands running.
Yeah, so very clear manual interaction. I think this is something we're going to see a lot more. I think maybe the past 5 years, there's been a lot more automation. But as more of these technologies become prevalent, we're going to see a lot more, I guess, research style attacks like this, even for existing exploits. Good perspective. Thank you.
Yeah, and that was like the second biggest find. Like, for us, that's the second key takeaway from this incident, that the answer here wasn't obvious. We looked for the obvious attack vectors and the obvious CVs, and we couldn't find anything, and really had to dig deep. We could have just said, okay, we alerted the customer, that's it, our job is done, there's no more work to be done. But our the fact that we focused and wanted to dig in and really understand how the attacker got in, and had to dig deep and read some code of some open source project that we never heard of before, that's where you get the most interesting findings, where you have to dig deep and you have to find what actually happened. And you just don't just say, okay, I alerted the customer, we can move on to the next incident. And we submitted it and we got our own published CVE, which is exciting for us. Personally, for me, it was the first CVE I was attached to, so it was very cool. And now we have a small demo sort of how the attack works. I promise you that in PowerPoint it's fully animated and it looks really cool. Here we will just see it in a bunch of stills, but it still looks nice. So this is our Gogs machine. You have your own repositories. These are private code that you own, that you want to protect. So you created your own Gogs repository, your own self-hosted server. Now, our attacker creates a user and then creates multiple malicious repositories, as we saw in our victim's machine. Those multiple random-looking repositories in your server. Now, they can do that because on Gogs, user creation and in repository creation are enabled by default. You have to actively disable open registration for it to be disabled. So the attacker creates multiple repositories, each one containing a symbolic link to the Git config file, basically executing a single command, which allows them to then download and implement a full malware on the machine, having complete takeover of the server with full control over the private code that you have there, and they can extract that to do whatever they please, or just use the server itself as a node for other malicious activities, or just compute for crypto mining or anything like that. Wait a minute. Yes. And now we were on the part that we started hunting the actor themselves.
So yeah, at this point of the investigation, we know of one victim that was targeted by or just sprayed by this threat actor. And we wanted, of course, to expand our investigation and see how many more victims there are in the world. So first thing, as a threat researcher, open Showdown and see how many exposed Gogs servers there are worldwide. We found out there are almost 1,500 at that time of the investigation. Now I think there are more. And we started to investigate some of them just manually, opening them up, and we saw the same pattern that we saw before. Those random looking repository name and usernames that were created, and that they were created in the same time frame that our own victims machine had the same repositories that created. So we're seeing this kind of weird thing that we see. We know that we need to investigate more, and looking at one of these repository, just by clicking it, we see the same .git config file. So of course I write a short script that looks at all of the Showdown exposed instances and see if the same pattern repeats itself. And we look for this random owner and repo names, and they have to be exactly 8 characters long. And the results, we found over 700 servers that were infected in the same way. So all of these servers had this random looking repository, and they all contain the .git config file. So looking at, So that brings us to the third key takeaway, which is that any unique pattern can be used as a behavioral indicator of compromise. So in this case, we took the repository name and use it as a pattern to search for other victims in the wild. So use it to scan every exposed instance and search for the same pattern, and take it as the behavior that the attackers are performing in the wild, to see how many victims there are in total. Now, going into one of those .git config file and looking what the attackers are doing, we saw some things that, again, seemed similar to our own previous investigation. So first, we saw the SSH commands. So wait, I don't know if okay. So it was the same C2 server that the attacker was using, which indicated for us that we have one main threat actor that is trying to exploit other servers as well. And not sure about okay. Yeah, so we have those 3 SSH commands, and the same file hash was the same in all of the servers that we looked at manually. So we know that we have this the same threat actor. And next, the thing is to build an attacker's profile. So it's kind of related to what we talked before. We try to understand who is these threat actors and what is their motivation, and so what is their end goal. So first, we have this attacker. We know that they are very opportunistic. They try to attack as many servers as they can. Essentially every exposed GOG server on the internet, on Shodan, that they can find. And they're trying to do it in the quickest way possible. So they're not trying to do it in a very long time, just very fast. They're very aggressive. They're not trying to be stealthy, as Gili said. They could have hide their traces. They could have deleted some of the repositories and tried to attack in a more stealthy way, but they didn't. So all of these, they're being so opportunistic, being aggressive, leads us to the conclusion that this is the financially motivated threat actors. So it's important to note at this point that we only had the visibility into our own customers' environment. We couldn't investigate other machines. And we later see the payload that this threat actor dropped into our own victim's machine. But in total, the behavior that we've seen really fits into a threat actor that is financially motivated, trying to gain money fast by either deploying crypto miners or by just controlling servers.
Now, that post-exploitation activity, did you see was there any, many times in ransomware cases, for example, you'll see like an initial access broker, or you'll see a distinct change in TTPs in the middle, like in the evidence. After we saw some changes at the beginning, or you saw some changes at the beginning, after they gained access, did you see anything different? Like, was there any sort of is this a brand new piece of malware? Did they deploy different categories of malware? What did that look like?
I think we just saw this one malware that Gili will describe in more detail in just a few slides.
Awesome.
And we saw the same, it was the same file hash across other victims as well.
And was this a custom piece of malware?
No.
Yeah, and we're just that's immediately our next slide. So that's a great question. And also, as Yara mentioned, we can't tell you the exact full post payload activities on other machines, because obviously we only have visibility to our own customers, and they were very quickly alerted on the issue and fixed and deleted the machine. So maybe a different wave, or sometimes later, a different piece of malware was dropped, but we couldn't tell you because our customer was protected. And now let's go to the malware deep dive. That's my favorite part because, as we mentioned, I am a malware researcher. So we saw the payload. We downloaded it from the same C2 server that we saw in the attacks. Immediately, I start looking at hex, and I saw this UPX header. Now, a UPX header means that the binary is custom compiled to be packed, which means it is smaller on disk, but also all the strings and all the code is hidden and only unpacked during runtime. Attackers really like to use this trick to make static analysis harder, but it's very easy to bypass. You have the unpacker tool that takes this binary and takes the inner binary that is executed during runtime and spits it out. And now, after UPX unpacking, I am left with these random-looking functions and strings that are still not very readable. That is because the internal payload was built using GoGarble. As I mentioned, this is why we got here in the first place. That was our initial piece of initial hint for the compromised activity. Luckily for us, the good people at Mandiant created the ungarbling tool, which is a very cool and easy to use tool with a very hard to pronounce name. So this tool allowed us to extract very specific and malicious looking strings from the binary. It basically takes all of these strings that are hidden in the binary and are only decrypted during runtime, and using some emulation of the decryption function, opens them up statically. Now, with unique strings like gutskill command goodbye, we were able to Google and search for these in our open sources, and we found that the malware was a custom compiled version of a framework called Supershell. Supershell is both a attack server and a payload generator, which has support for both UPX packing and Go garbling of the payload, which will fit with our customers when we're victims' payload. And it has very specific commands. It basically allows an attacker full command, very easy to use a command of the server, of the infected server with remote code execution. Now, Supershell is not entirely new. It was featured in many high-profile campaigns, usually in Southeast Asia. So that might hint at our attacker's source, but that's only speculation. Here is some reports of Supershell and other similar exploits of internet-facing servers and applications. And there's this report by Mandiant and another report by Checkpoint. Again, in all those reports, a CVE or some 0-day was exploited to install Supershell on a machine to then do whatever manual work the attacker wanted. And now that we knew that the malware was specifically a variant of Supershell, we knew where to look inside the malware to find the C2 server that the attackers were connecting to. Right here in this function, you can see the IP and the port. We then pivoted and tried looking for other references to this specific server online. And we actually saw that this specific path on VirusTotal, which is the C2 server, /Supershell/compile download Gogs, which basically confirmed our suspicion that this was indeed a Supershell C2 server with a custom compiled payload specifically to attack Gogs. So now we have the full story of what happened. I have to mention that at the time of our investigation, the servers were already offline, which means the attacker did what they did as quickly as possible, extracted whatever information they wanted, or they tried to get at least, and then very quickly shut everything down. So they'll be harder to investigate later. Let's see.
Okay. So if you're thinking or wondering if you or your server are vulnerable for this vulnerability, or you were attacked by the same threat actors, we'll now look at all of the things, the steps you can take to check for yourself, to check yourself. So first, if you're running an older version of Gogs, so if the version you're running is less than 13.3 or equal to it, then you might be vulnerable to this 0-day. So the best thing to do would just be update to the latest version, which came out about a month ago. So we'll see the full timeline in a few slides, but yeah, it took some time in order for the vulnerability to actually be patched. So if you are by chance running the Gog server, just make sure that you have the latest version running, because you're definitely vulnerable if you have an older version. Then you must have the open registration feature enabled. So this is by default. It's enabled, which allows anyone to register, any user to just register to your Git server. So if you can't patch to the latest version by any reason, make sure you disable the open registration, and if you don't need it for any good reason. It's not recommended to, if you have an exposed Git server, and also allow users to register. And of course, the Gogs server has to be exposed to the internet. So the best thing to do, and this is like a more general advice. So any sensitive server that you're running, make sure to limit your external exposure. So that means if you can use VPNs, or just limit the IP addresses to the ones that you are sure should log in, should access your server. And if you have sensitive data over there, then yeah. So this is just more general advice. Now we're getting to the full timeline of the attack flow. First, we know that on July 10th, we saw the first indication of exploitation on the victim server, which was after the latest version, the previous latest version was released by Gogs, which led us to the conclusion that we found a 0-day, because the machine was had the latest version running, and we saw some malware on it. We only found the malware a few days later when we had the malware alert, the malware finding alert, and we started the investigation, and we quickly came to the conclusion that this is a new 0-day and not some previous vulnerability, and that the server may have been not have been patched or some misconfiguration. No, because again, everything was patched to the latest version. We didn't find anything else, and after the investigation, we found the same vulnerability probably as the threat actors found. And we then reported it to the Gogs maintainers. They did acknowledge that the vulnerability exists and is valid in October, but it was only fixed, as I said, in January of this year, so just a few weeks ago. And in the meantime, in November 2025, we saw another wave of attacks. So this 0-day was still being actively exploited in the wild. Also, in the last time when we gave this talk at the BlackHat, we really saw just a few days before another wave of exploitation. Yeah, Gil, you want to summarize?
Yeah. Yes, sure. So that leaves us at the end of our talk. We just have a few things to emphasize again. These are what we consider the key takeaways from the investigation, the thing that we learned most and we think should be shared with every security practitioner. First is what we call connecting the dots. We correlated detections from several sources to have a very strong indication of compromise. We knew that there was an exploit and threat alerts and a malware alert, and we combined those to have a very, very strong signal to know that this was an interesting case. Those connections of weaker signals to one strong signal is very powerful, and we use it a lot in a lot of different instances.
Yeah, and expanding on that, I think it was really interesting that we didn't stop with just after we found the malware. So most researchers that are investigating malware or investigating threats find the malware, and that's their end goal. They they investigated the malware, you see what are the C2 servers, and stop there. But when we dig deeper, because we wanted to dig deeper into this, we found really interesting finding. And in this case, this was the 0 day that we found. So by looking deeper, reading the code, seeing what hints from previous CVEs, you can find in your case or in other cases just the more interesting findings.
And the first thing that we want to mention, just because it's very unique and special in this investigation, was that we tracked the attacker by looking at the random looking repository names and usernames that they created in multiple servers. That is not an IOC that you would read about in some random in any random blog. But we think that you should consider any unique or interesting behavior, and those things should be documented as much as possible. Because even if you think something is not trackable or can't be used as an IOC currently, it might be possible to use in the future, and it could crack an investigation that someone else is working on. Like, document as much a unique behavior as you can, and publish when you can, like we did in this talk. And we think that using creative IOCs will allow us to track attackers in the future when hashes and IPs are already known to be weak, and attackers can bypass them easily with polymorphic malware or just having VPNs and very quick IP replacement. So we need to be more creative with our IOCs in order to track more sophisticated attackers. And that's it. Thank you all for listening. And if you have any questions,
Awesome.
discussions, we would love to answer.
Awesome. Thanks, Gili. I do have a couple of questions. I'm not seeing much from the audience, but I do have a couple of questions. Number one, so there was 700 customers or 700 victims that you identified that you were able to remediate the problem, but there was another set of customers beyond that, or another set of victims beyond that. What do you think the victim notification process looks like for an open source project like this?
Honestly,
maybe non-existent.
With our interaction with the specific maintainer, I assume the solution was he patched it and didn't say anything to anyone. This specific project, as Yara mentioned, it took a lot of time until it was fixed. He was very non-communicative with us, and there wasn't any major notification or anything for users as far as we can tell. And that's really on if a company that had this software in their environment, they really had to be on top of things. They then really had to make sure that they updated it and knew that this update was critical. Because by the time the CD is published, multiple attackers knew that they can exploit it, multiple attackers know how to scan it. After we published a blog about this, and multiple POCs appeared online. So any company that didn't know to update might be vulnerable. And that's really a big issue with these type of open source projects when compared to well-maintained and well-developed projects.
Yeah, agree.
Yeah, I think anyone using open source projects need to be aware of the risk, security vulnerabilities, and try to keep their systems secure in other ways. So if you have any, it can be even misconfiguration. So if your setting are misconfigured in a wrong way, that also can lead to a server compromise. And of course, new CVEs that come out, you have to be up to date with them and patch your systems in time to keep if you have users, then keep them safe.
And how many of these victims do you think just had no idea that they even had Gogs repos installed in their environment?
I think it's very, very easy to imagine a company where some intern or someone tried to experiment with internal and self-hosted Git. It tried a bunch of projects. One of them was Gogs, and he just never disconnected it. And then he lives, his environment is left away to attackers, and they have no idea.
It's very scary, and it does very much harken back to the days of Shadow IT, where we dealt with all types of things that were installed. Of course, there was everybody I'm sure remembers the spate of Adobe, even those were monitored, the Adobe vulnerabilities that were hard to track down back when Adobe wasn't centrally managed or anything along those lines. I think the problem is going to be 10x worse this time with all the AI that we're using, all the things that we're building with vibe coding, giving things like OpenClaw access to our systems to install whatever we want. We've got some folks doing that on their local systems. We've got some folks doing that on EC2 or cloud compute, so on and so forth. I think you touched on one thing that's going to be mission critical for us as responders and threat hunters going forward. Sometime in the past 10 or 15 years, a lot of times when we talk about threat hunting, we are looking for those IP addresses or those hashes or those file paths and things along those lines. But prior to that, prior to the SIMs and our log aggregators and things focusing in on those handful of IOCs, it really was an art where you had to identify those unique patterns, whatever they may be. And I think that's going to be a skill set and a capability that we're going to have to bring back into the front. This is what it's going to mean to have a world-class incident response program and tier 1 operators, is the ability to look at that direct evidence, something beyond just those IP addresses, beyond that telemetry data, and beyond those hashes.
Yeah, exactly. I think that in general, behavioral IOCs are important in this era. Try to see how the attackers are operating, what traces they leave on systems, and try to search for those and not just static IOCs.
Agreed. We do have one question from the audience. Did you use threat intel to first go down this path? Or did a customer bring you in to investigate? So I think the question is around, how did you first find out about the compromise? Is that right, Stuart?
Yeah, so it's a bit of a combination of both, because it started with our threat intel alerting us that Gogs was a running issue in the malware in multiple incidents, which led to us creating this signature. And then our own signature, our own anomaly detection, found the binary in the victim's machine. The specific customer had the intrusion, never came to us with that malware. We found it with our residents, but they insisted that part of the investigation regarding those go-garbled binaries at the start was a result of us being up to date on threat info and seeing rising trends. We can't detect everything to focus on what we can. Does that answer the question?
Makes sense. So it sounded like it was a detection. You were breaking up a little bit there. So it sounded like it was a detection on the C2 malware, like you might see for Empire or any of the other ones that are out there. I can't think of the one that I play with the most.
Yeah, it started our Yaga rule to detect the binaries. The customer didn't approach us. We had to detect it using our anomaly detection on the binary.
Sounds great. One last call for questions from the audience, and then if we don't get anything, I think Steve will be closing us out in here in just a minute. Awesome. Steve, if you want to pop in, I don't see anything else from the audience. It's been a really great session.
Absolutely. Thank you all for an excellent presentation. Just a couple of things we'd like to remind our audience. If you would take a moment to check out our survey at the conclusion of the broadcast, we'd greatly appreciate your feedback. We want to thank our panelists, and we appreciate your time and expertise on today's topic. I'd also like to give a big thank you to our sponsor, Binalyze, as well as to everyone in the audience. We appreciate your attention and participation. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been able to listen to this event. This webinar is copyright 2026 by Informa, and the presentation materials are owned by or copyright by Informa. Individual speakers are solely responsible for their content and their opinions. And on behalf of our panelists and Binalyze, I'm Steve Paul. Thank you for your time and have a great day.